Hello students, let us solve this example of order 5. So since it is of order 5, we cannot use a calculator. We have to simplify it. Either use synthetic division or just simplify manually. And then since it's a homogeneous equation, the solution is given by complementary function. So let us write auxiliary equation. Auxiliary equation, or before that you can write use the operator. So if you use the operator, d by dx equals to d square upon dx square equals to d square, and so on. Therefore, if suppose this is equation 1 implies d raised to 5 minus d raised to 4 minus d plus 1 into y equals to 0. Now we write the auxiliary equation. So replace the value of d by m and then exclude y equal to 0. So this will be equals to m raised to 5 minus m raised to 4. See, m cube m and m square is not present, right? Then minus d is minus m plus 1 equals to 0. From these two terms you can take m raised to 4 common. So if I take m raised to 4 common, m raised to 4. So from the first term you will remain with m, and the second term you will remain with 1. Then minus of m, if you want here my plus, we should take here minus 1 equals to 0. So this equation implies m raised to 4 minus 1 into m minus 1 equals to 0. Alright. So if I consider m minus 1 equals to 0 implies you are getting one of the root is equals to 1. So let me write this one, root m equals to 1. Then okay, so this is first one. Second one we have got here m raised to 4 minus 1 equals to 0. So this can be written as m square d square minus 1 square equals to 0, right? So this is a square minus b square, which can be written as a plus b, a minus b. So I can write it as m square plus 1 into m square minus 1 equals to 0. Okay, therefore now m square plus 1 equals to 0 will give you the root m equals to plus or minus I, right? Then m square minus 1 equals to 0 will give you the root m equals to plus or minus 1. Okay, therefore since it is of order 5, how many roots we should have? We should have 5 roots, and thus we have obtained the 5 roots, and the 5 roots we have obtained are okay, m, the first root 1, then we have obtained plus or minus I, then plus or minus 1. Okay, so I can simplify and write this is 1 and 1, so repeated. So 1, one more 1, and then minus 1. Okay, then plus or minus I. Okay, so now 1 and 1 is repeated. So for repeated root, how to write the complementary function, and then for complex root, how to write the complementary function. Okay, so the complete solution y or yc for this homogeneous equation is given by, for this root 1 and 1 we write it as c1 plus c2x into e raised to 1x. Then for minus 1 we write it as c2 into e raised to minus 1x. Then plus for 1 plus or minus I. Okay, for plus or minus I, see, plus or minus I implies here we have 0. That is, value of P is 0, real part, and Q imaginary part is equals to 1. So with this respect, we write complementary function as e raised to value of p is 0 into x into the bracket c1 c2, so this is c3. Now let us write c4 cos q is 1x plus c5 sine of 1x, right? So let us simplify and write the answer. So y equals to c1 plus c2 x into e raised to x plus c3 e raised to minus x, right? So close this bracket here itself. C1 plus C2 x into e raised to x plus C3 into e raised to minus x plus e raised to 0 into 0 into x is 0, e raised to 0 is 1. Okay, we know value of e raised to 0 is how much? E raised to 0 is 1. So substitute here. So since e raised to 0 is 1, you will remain here with c4 cos x plus c5 sin x. Okay, this is what the required solution. This is the final answer for the given homogeneous differential equation.